Hello class, this is our Unit 3 review guide for the test, and this is part 1. For the first question I have, is this the following probability model, and this one over here on the right, and then what do we call the outcome yellow? So in this case, we could see each of these probabilities are between 0 and 1 inclusive, and if we add them up, they are not going to be 1. Right? If we add these up, we get, let's see, 0.45, excuse me, 0.5, 0.75, and then 0.90, which is not 1. So since the sum is less than 1, this table is not a probability model. And then what do we call the outcome yellow? Well, that's a probability of 0. So yellow, I'll put that in quotation marks to highlight what that is. That's the event in this case. Yellow is an impossible event, since its probability is 0. Question 2, I have that the sample space S be the numbers 1 through 10, assuming each outcome is equally likely. We want the probability of E, an event, the event E, an odd number less than 10. So in this case, we have a total of 5 odd numbers less than 10. 1, 3, 5, 7, and 9. And there's a total of 10 entries, 1 through 10. So this is 5/10, or 1/2, or as a decimal, as they will probably make you write it, 0.5. Question number 3 here. I have a probability experiment is conducted in which the sample space of the experiment is S is equal to the numbers 6 through 17. Event F are the numbers 7 through 11, G 11 through 14. Assuming that each outcome is equally likely, we want the outcomes in F or G. So that's listing all the numbers in F, listing all the numbers in G, and not having any repetition. So all the outcomes in event F are 7, 8, 9, 10, and 11. And then the remainder from G without repetition, 12, 13, and then 14. Squeezed in there in the end. We want the probability of F or G by counting the number of outcomes in F or G. All right, so probability of F or G. We have here 1, 2, 3, 4, 5, 6, 7, 8. And we would divide that up here in the sample space S by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This would be 8/12, or 2/3, or rounded to 3 decimal places, which they will ask you to do, 0.667. And then finding the probability of F or G using the general addition rule. It's probability of F plus probability of G minus the probability of F and G. So in the fractional format, there is a total of 5 numbers here in F. Divided by the total number of the sample space, which is still 12, so 5/12. In the event G, there's a total of 4 out of 12. And the events F and G just share one number, the number 11. So we're going to subtract 1/12. As decimals, which they will make you do. This would be 0.417 plus 0.333 minus 0.083. This would give us 0.667, or as a fraction, that would be 2/3. But they would make you round it to 3 decimal places regardless. Question number 4. I have, we're going to find the probability of the indicated event. If probability of E is 0.20, probability of F is 0.35. We want the probability of E or F if the probability of E and F is 0.05. So just to quickly write that as a in the formula, this would be the probability of E or F. Probability of E plus probability of F minus the probability of E and F. So 0.20 plus 0.35 minus 0.05. This will make 0.55 minus 0.05. This will make 0.5. For question number 5, now suppose the events E and F are independent. So probability of E is 0.4, probability of F is 0.8. We want the probability of E and F. So this would be probability of E times the probability of F, since these are independent. 0.4 times 0.8. We will be left with 0.32. For question number 6, I have about 20% of the population in a large country is nervous around strangers. If 2 people are randomly selected, what is the probability that both are nervous around strangers? And then what is the probability at least one is nervous around strangers? So probability of both of them being nervous. We would just take that probability of 0.20 at 20% and square it. We will get 0.04. For the probability of at least one being nervous, this will be 1 minus the probability of neither of them being nervous. So 1 minus, if the probability of being nervous around strangers is 20%, then the probability of not being nervous around strangers, or the complement, will be 1 minus 0.20, so 0.80. And we would square that since there's 2 of them. So 1 minus 0.80 squared is 0.36. For question number 7, I have supposed that E and F are 2 events, and that the probability of E is 0.6, probability of F given E is 0.3. We want the probability of E and F. This would be the probability of F given E times the probability of E. This would be 0.3 times 0.6. That would give us 0.18 for the probability of E and F. And then finally, for the last part of this first part of the this review, I have question number 8. The data in this table represents the number of driving fatalities for a certain area by age. for male and female drivers, we want the probability of randomly selected driver fatality who was female was greater than 70 years old. So this would be the probability of being female that's greater than 70. This will be the probability of being female and greater than 70. Divided by the probability of being female, since this is a conditional probability due to the way that this was written about that the randomly selected driver fatality who was female was greater than 70. Notice how there was no and in that sentence. In our case, if you look at this, 70 or older, 1,226, divided by the total of the female column. This should be 16,079. You divide those, you get an answer rounded to 3 decimals as 0.076. For part B, I have what is the probability that randomly selected driver fatality who was greater than 70 was female. So this would be greater than 70 and a female. This is going to be, again, the probability of being greater than 70 and female. And this time now, it's going to get divided by that probability of being greater than 70. This will be still that 1,226. But now we are adding these two numbers to get 4,271. That gives us 0.287. And then finally, is a victim of a fatal accident age greater than 70 more likely to be male or female? So based on these two values, as we can see, they're both small in terms of this table. So the driver is more likely to be male. To be male, because the probability is greater than a half, or 0.5. Again, how can you tell that? Because this number, well less than a half, and this one's even smaller than a half, because both of these are well less than a half. That's why the probability for the male being in a fatal accident greater than 70 is indeed more likely. So that's it for this first part of this Unit 3 review. Stay tuned for the second part. Thank you.